Structural formulas are a fundamental concept in chemistry that reveal how atoms connect to form molecules. Unlike other types of chemical formulas, structural formulas show the actual arrangement and bonding between atoms, giving us a visual map of molecular architecture. A structural formula is a representation that shows how atoms are bonded together within a molecule. It goes beyond simply counting atoms by revealing their connectivity and arrangement. This type of formula tells us which atom is connected to which and how they're linked together through chemical bonds. Let's compare two ways of representing the same molecule. The molecular formula C2H6O only tells us the types and numbers of atoms present: 2 carbons, 6 hydrogens, and 1 oxygen. In contrast, the structural formula CH3-CH2-OH shows us exactly how these atoms are connected. The carbons are bonded in a chain, and the oxygen is attached to the second carbon as part of an OH group. Chemists use 3 main types of structural formulas, each with a different level of detail. Condensed structural formulas group atoms together without showing every single bond, making them compact and easy to write. Expanded structural formulas show every bond explicitly using lines between atoms, providing complete bonding information. Skeletal structural formulas represent the carbon chain as lines, with carbon atoms implied at line ends and vertices, while hydrogen atoms are typically omitted for simplicity. Here's an example of a condensed structural formula for ethanol. It's written as CH3CH2OH in this format. Groups of atoms are written together as units. The bonds between these groups are implied rather than explicitly drawn. This makes the formula more compact while still showing the basic connectivity of the molecule. The expanded structural formula for ethanol shows every single bond in the molecule. Each hydrogen is explicitly connected to its carbon with a line, and the carbon-carbon bond is clearly shown. The oxygen is bonded to the second carbon, with its hydrogen also explicitly drawn. This complete representation leaves no ambiguity about how atoms are connected, though it takes up more space. Skeletal formulas use the simplest notation, especially useful for larger organic molecules. In this representation of butane, each line represents a bond, and each vertex or line ending represents a carbon atom. Hydrogen atoms bonded to carbon are not shown, they're simply understood to be present to satisfy carbon's need for 4 bonds. This streamlined format makes complex molecules much easier to visualize. Structural formulas are essential tools in chemistry for several reasons. They reveal connectivity between atoms, showing us the molecular skeleton. They highlight functional groups, which are specific arrangements of atoms that determine chemical behavior. This helps us predict chemical properties and reactions. Most importantly, structural formulas are the foundation of organic chemistry, where understanding molecular structure is key to understanding how compounds behave and interact.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.